Hey guys, welcome to Amra Ventures. I am Pritham and today we are going to do some typical problems on RH criteria. In the previous video, we have seen that what RH criteria is, how we can find the stability by RH criteria and how to write it in tabular form. And we have seen some basic problem also. Now in this video, we will see some typical problem. So we have to find the stability of this one. Now we have to know one rule. Whenever only one element is 0 in the first column, replace 0 by smallest positive constant epsilon and continue the Routh stability. Finally, substitute epsilon equal to 0 and check the number of sign changes in the first column. If any sign changes occurs, the system is unstable. So if any 0 is present in the first column, we have to replace it by epsilon. In the earlier video, we have seen that how to write it in tabular form. The coefficients are 1, 1, 2, 2, 3, 15. So we have written it in this way 1, 1, 2, 2, 3, 15. After that, we have calculated these coefficients. We know that from the first two row we will write from the characteristic equation, and from the next one we will calculate. So after calculating, we found that this is 0. 1 into 2 minus 1 into 2 by 1, so it is 0. This one is minus 12 and this is 0. So we have to replace the 0 in the first column by epsilon. After that, we need to continue our calculation. So this coefficient is 2 into epsilon minus 1 into minus 12. So it is plus 12 by epsilon. For this one, it is epsilon into 15 minus 1 into 0 by epsilon. So it is 15. And if we consider it as A, then A into minus 12 A minus 15 epsilon by A. For this coefficient, it is A into 0 minus epsilon into 0 by A is 0. Again 15 into this term by this term. So it will be 15 because this is 0. Now by the rule, we have to put epsilon equal to 0. If we put epsilon equal to 0 here, then what we will get? If we put epsilon equal to 0 here, we are getting a positive term. Now for this one, if we put epsilon equal to 0, so it is 0, this term A cancel out, it is a negative term. So this one is positive, this one is negative, again this is positive. So how many number of sign changes? For the system to be stable, there must be no sign change in the first column. This one is positive, 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 negative, positive. So number of sign changes is 2. And total number of roots are 5. Total root is 5. Number of sign changes is 2. That means number of pole in the right hand side of the S-plane is 2 and the number of pole in the left hand side is 3. Now in this problem, we will find the location of the poles. So first of all, we need to draw it in a tabular form. S power 5, S power 4, S power 3, S power 2, S power 1, S power 0. So the coefficients are 1, 1, 3, 3, 2, 2. We will write in this manner 1, 1, 3, 3, 2, 2. After that, we need to calculate these coefficients. 1 into 3 minus 1 into 3 is 0. 1 into 2 minus 1 into 2 is also 0. Now for this, we need to know one rule. Whenever in the Routh tabular form, the entire row becomes 0, then we require to form an auxiliary equation by using the previous row coefficient. Then differentiate the auxiliary equation and replace the zeros by the differentiated coefficients. That means we need to form an auxiliary equation by these coefficients, which is 1 into s power 4 plus 3s square plus 2s power 0. If we differentiate it, we will get 4s cube plus 6s plus 0. Now we will put these coefficients here. 4, 6 and 0. Now again we will continue to calculate the coefficients. 4 into 3 is 12 minus 6 by 4, which is 6 by 4, that is 3 by 2. 4 into 2 minus 1 into 0 by 4, it is 2, 0. Again 3 by 2 into 6, 3 by 2 into 6 means 9 minus 4 into 2, 8 by 3 by 2. 9 minus 6 is 1, it will be 2 by 3. For this one it is 3 by 2 into 0 minus 4 into 0, it is 0. And for the last one it is 2 into 2 by 3 by 2 by 3, it is 2. Now in this problem we need to know total number of root will be 5 and the row of 0 is in S power 3. That means the number of poles which are symmetrical about origin is 4. If the row of 0 is in S power 1, then the number of symmetrical pole about the origin will be 2. So here the number of symmetrical pole about origin is 4. And one more thing is that we have to notice the number of sign changes below the row of zeros. If below the row of zeros no sign change is there, so all the symmetrical pole will be in the imaginary axis. And if any sign changes is there, it will be in the real axis. It will depend on the number of sign changes. Here no sign change is there, so all the 4 poles will be in the imaginary axis. It is symmetrical about this, and this one is symmetrical about this. And above the row of 0, no sign changes is there, so the last pole will be in the left hand side of the S plane. From this we can also find the location of the pole. We can only find the location of the pole which is symmetrical about the origin. How we can find this? We can find it from the auxiliary equation. It is S power 4 plus 3s square plus 2. We can, if we write it in this fashion, s square plus 1 into s square plus 2, it is similar to this one. So we can from this we can find the location. S equal to plus minus j and s equal to plus minus root 2j. So here it is plus minus j and here it is plus minus root 2j. Now moving forward, one more thing is that whenever in the a row of 0 comes, the system can never be stable. It will be always it will be marginally stable or unstable. Now how these two cases will come? If there is no sign changes and it has a row of 0, then it is marginally stable, and if there is sign changes and it has a row of 0, then it will be unstable. Now for this thing, let's suppose it is the condition for marginal stability. Let's suppose we found that the number of sign changes are like this in the first column. Now we will draw how many poles are there and how they are distributed in the S plane. The row of zeros is in the S power 3. That means the number of symmetrical pole is 4. So where these 4 poles are there, we have to find where these 4 poles are present. The number of sign changes below the row of 0 is 1. That means one symmetrical pole is surely there in the real axis. So if one symmetrical pole is there in the right hand side, then one symmetrical pole will be there in the left hand side also, because it is symmetrical about the origin. So two poles are there in the real axis and 2 poles will be there in the imaginary axis. These 4 are symmetrical. And one more sign changes is there above the row of 0. That means it will be in the right hand side of the S plane. The number of sign changes tells us about the number of poles in the right hand side of the S plane. One sign change is there. That means the number of pole in the right hand side of the S plane is 1. If it is in this fashion, so how many poles are there? Total number of total number of roots are 5, and total number of symmetrical pole is 4, and the number of sign changes below the row of 0 is 2. So it means the number of symmetrical pole will not be present in the imaginary axis. The 2 pole will be there in the right hand side and it will be symmetrical. That means it will be like this, and there is no sign changes above the row of 0, that means one more pole will be there in the left hand side. It can be here or here, it doesn't matter. Means 3 poles are there in the left hand side. In the left hand side 3 poles will be there, and the right hand side 2 poles will be there. Now in this problem we need to find the pole location and whether the system is stable or not. First of all, we need to form the Routh table. S power 6, S power 5, S power 4, S power 3, S power 2, S power 1, S power 0. And now the coefficients are 1, 3, 4, 6, 5, 3, 2. We have to write it in this manner: 1, 3, 4, 6, 5, 3, 2, 0. Now we know that we need to calculate these coefficients from these two. 4 into 3, 12 minus 6 by 3. It is 2. 3 into 5, 15 minus 3 by 3. It is 4. 3 into 6 minus 1 into 0, 0 by 3. It is 2. 0. Now from this one, 6 into 2, 12 minus 12, it is 0. Again 3 into 2 minus 3 into 2, it is 0. And these are 0. So we know that if any 0 row occur, then we need to form the auxiliary equation from the previous row, which means 2s power 4 plus 4s power 2 plus 2 into s power 0. If we differentiate this one, we will get 8s cube plus 8s plus 0. So we will replace it by 8. Then we need to calculate this s power 2 row. 4 into 8, 32 minus 16 by 8. So it is 2. Again 8 into 2, 8 into 2 by 8, it is 2, 0, 0. Again in this row, 8 into 2 minus 8 into 2, it will be 0, 0, 0, 0. So we found another auxiliary equation. We need to find another auxiliary equation from this one. 2s square plus 2s plus 0. So if we differentiate this, we will get 4s plus 0. Now we have to replace it by 4. Again we have to find this coefficient from here. 4 into 2, 8 by 4. It is 2. Now in this question we have 2 rows of zeros. This one and this one. Which means the row which are symmetrical are repeated. Means repeated poles are present. Repeated poles are present here. The first row of 0 occurs at S power 3, means 4 symmetrical poles are there which are present in the imaginary axis, which you can say that there is no sign changes after the row of 0. So all of the poles are in the imaginary axis and they are repeated, means they are repeated in the imaginary axis. And 2 more poles are there which are present above the row of zeros and there is no sign change, means they are in the left hand side. Here in this question it has repeated poles and all of these are in imaginary axis and 2 poles are there in the left hand side. Since it has repeated poles, the system is unstable. In this question, they asked about the number of poles in the right hand side of the S plane. We can see from the question only that this is not stable. Now they have given that the system is unstable. They didn't ask about whether the system is stable or not. They asked about the number of poles in the right hand side of the S plane. So we will make the table first. For 2, S power 1, S power 0. Here the coefficients are 1, 1, 0, minus 1, minus 1, because S power 2 term is absent. So coefficients are 1, 1, 0, minus 1 and minus 1. 1, 1, 0, minus 1 and minus 1. Now from this row we need to calculate the coefficients. 1 into 0 is 0, minus 1 into 1, it will be 1. This one 1 into minus 1 by 1, it is minus 1, it is 0. Now in this one it will be 0 because 1 into minus 1 minus of 1 into minus 1, it is 0, and this is also 0. So we need an auxiliary equation. It will be 1 s square plus 1 s square minus 1 into s plus 0. If we differentiate it, we will get 2s. So we'll put the value of 2 here. After that, we need to calculate this coefficient. 2 into minus 1 by 2, it is minus 1. Now we can say that the row of 0 is this one, and below that one sign change is there. The number of symmetrical pole is 2, and one sign change is there. That means the pole is in the right hand side of the S-plane, and the symmetrical pole is one symmetrical pole will be there in the left hand side also. And there is no sign change before the row of 0. That means 2 pole will be there in the left hand side. That means in total 1 pole is there in the right hand side. So the question is the number of pole in the right hand side of the S-plane, which is 1. So friends, in this video we learned how to find the number of poles and what are the stability criteria, how we can say that the system is stable, unstable, or marginally unstable. In the next video we will solve some more problem on different topics of RH criteria. So friends, if you like this video, do like, comment, share, and please subscribe to our channel Amravik Ventures. Thank you.